Welcome to the course Statistics from the PreMSc. My name is Tammo Bijmold. I'm a full professor in the marketing department. I'm the lecturer for this course. This is the first knowledge clip of this course, and the topic for this clip is the role of statistics and data. Basically an introduction on what it is to do statistical analysis and what is the role of data in your research. The literature for this topic is chapter 1 of the book by Anderson et al. So the basic textbook that is obligatory literature for this course, and basically I covered the topic of chapter 1 in this session. So let's start with a somewhat formal definition of statistics. As it is described in the book, and I really like this definition, it's the art and science. So it's of course, it's a scientific area, but also an art. Not everything is as objective as you would expect. And that is the collecting, analyzing, presenting, and interpreting data. So statistics both covers how you get the data and tools to do that. And analyzing the data, of course, that is the most important part, but also how you present and interpret the data. So all of that is an important aspect. So in the end, it's the result from going from your hypothesis to collecting data to presenting your results. All of that is covered in statistics. And this course is discussing most parts, mostly analyzing and presenting data, actually. You could also argue that statistics is about providing information based on data, and then information that is relevant for decision making. So you can imagine if you work in finance and you wanna invest in certain stocks, then there's a lot of data available on stock market prices and changes, and in environmental factors and all kind of other drivers. And you want to use this data, and you want to use statistical analysis to get information to make decisions about whether you want to buy or sell certain stocks. Now, to some extent, statistics is somewhat outdated word. Now there's a lot of really hype is to talk about data science, and to a large extent you could say data science is basically what used to be called statistics. Now, as I mentioned in the introduction, I'm a full professor in the marketing department, and I do a lot of research myself on product returns. Now, and this field is highly relevant and related to marketing, but also to operation management. Now, suppose there's a large online retailer like Amazon, or in the Netherlands bol.com, or Zalando, or something, some retailer like that. And of course, they have a lot of products and lots of customers, and this all leads to massive databases. A lot of what is happening in these companies leads to data, and which is stored in large databases. For example, they will have large databases on what products they have available online, with really detailed description of what these products look like, what the production costs and the costs are of these products, what the selling price is, but also all kind of other details at the so-called SKU level of the product. And potentially also what is in stock, how much is in stock of different products. And of course these information change over time, especially the potential price and things like that. Now, in addition, they will have a large database on customer behavior. So what is that specific customers, potentially at the individual level, what do they purchase, and maybe they don't keep everything that a customer buys, but occasionally things get returned. So this is all leading to data, which is stored in databases. And then, but what is available in terms of trucks and shipping, and what is the shipping cost for different products, and what is the options to return different products through different logistic systems. Logistics is also how much our operations, how much is available of the different products, and where is it available in the central stocks, or maybe at different locations throughout the country, and all this kind of information. And finally, there might be other information on, say, marketing, whether certain promotions have been done, whether advertising campaigns have been done, whether certain customers received an emailing or some other marketing advertising. and also things like about prices of products, but potentially also of competitors. So what have competitors been doing? So you can imagine it leads to really massive, large databases that are not only large, but is also continuously changing. Now all this information at Amazon or Zalando is available, and of course marketing managers at these companies can use this information to this data to obtain information. And then, for example, an analyst of say Zalando could run a project like, what are the drivers of product returns? What makes it that certain products are returned more often than other products? What are certain customers returning more products than other customers? Maybe it's related to promotions. If you do a promotion of a product, so a price discount, maybe not only sales goes up, but also the product returns goes up. So you can imagine running all kind of statistical analysis to see what is the impact. If I do a promotion, maybe I get double the sales, but also 50% more product returns, which makes the promotion less profitable. And this is done by analysts in these companies, but also by potentially master students doing an internship or a thesis project, or academic scholars like myself. So this is just an example from marketing and operation, and it should be clear that data and also statistical analysis of the data is really helpful to obtain information to make better decisions. And that is nowadays happening all over the place. So, which is another buzzword, which is data, big data. And whether you do shopping at the supermarket, or maybe through online surveys, or all kind of data within companies, or from online behavior or social media, at a continuous rate, massive amounts of data is collected and registered and stored in all kind of databases. And statistics or data science is about getting information, getting relevant information out of this data by structuring it, analyzing the data, and presenting the results. Now that leads to data science. Data science is being a really popular job nowadays. So just an illustration from Australia that data scientist is really a popular job, and even leading to a title in Harvard Business Review, which is a management journal. That data science is maybe perhaps the most sexiest job. So I'm not sure whether I convince you about that, but at least it should convince you that data science or statistics is really relevant for you as a student, but also later on in management practice. Because data and analysis of data through statistics or through data science helps you to support your decisions. Now, throughout this course, statistics, you will learn how to do this, how to run all these analysis, and how to conduct studies like I showed you here. How to do these things, how to analyze this kind of data to get this kind of information. Throughout the course and throughout the textbook, and later on in your studies also, you will see a lot of terminology in statistics, and it's good to sort of learn and to know these things. That's essential to understand what you're doing and what other people are talking or writing about. First of all, obvious is the central word is database or data set, which is basically the same. That's the total collection of all the data that is relevant for a certain topic, say in SPSS or in Excel. So you could say, the example that I just say, extensive databases. There's one database listing all the products that is available with all kind of characteristics about these products. There's another database listing customers and what they have bought, and so on. So these are all different databases or data sets, if you like. And for all these data sets, you could say they have the same structure, namely they have columns, and a column is a variable, like in this small example down here. You have the variable age and whether someone is married or not, and the address in different codes, and the income of the individual, and in categories income, and whether someone has a specific car and things like that. And a row is an observation or a case or a subject or whatever. So there's one element, one case from your data. For example, the purchases from individuals. So individuals is one row, and the different purchases, whether someone bought a different product, are the different columns. And each cell is called a measurement or a data point. So you should know these words like data matrix and a variable and cases and subjects, and I will be using them, and the textbook uses it, and in articles that you will be reading in your masters you will see these words. So you should know these really well, that you should not need to think like, oh, what again is a subject, what is a variable, etc. Now, again, like I said, I will be using these words, so I talk about variables here. So variable is something that you measure from a different individual. So it could be, like I said here, age, and whether someone is married, and where someone lives, etc. Now, there's different types of variables. And a classical way to make a distinction is at the level of measurement. Namely, there's 4 measurement levels: nominal, ordinal, interval, and ratio. Now, nominal, to start with the basic one, nominal is just a category, just a label. So the variable is just a label for something, like the name of someone, the country where someone is from, whether someone is male or female. So just a label, just a category, just a description. Then ordinal, that's also a category, but then there's an order also. So it's a rank, and the different order and the different categories are come in a certain order. For example, if you talk about sports competitions, like being first or second or third, etc. Or maybe in a survey, where if you do a customer satisfaction survey, and someone can rate between 1 to 5, from very unsatisfied to very satisfied, then it's a 5-point scale, and these are ordinal, because from 1 to 5 there's an order in these 5 categories. However, it's not interval scaled, because the difference between 1 and 2 is not necessarily the same as between 2 and 3 and 4 and 5, etc. So an interval scale requires that the difference between the different scale points is the same. So the difference between 1 and 2 is the same as between 4 and 5, or the difference between 1 and 2 is the same as between 101 and 102. For example, if I talk about temperature, degrees Celsius, the difference between 10 degrees Celsius and 11 degrees Celsius is the same as between, say, 41 and 40. And then there's ratio, which is also there's also the same difference between scale points, but then there's an additional characteristics, namely that 0 is a true 0 point is existing, and so there's a natural 0. For example, the age of an individual, the difference between 18 and 19 is the same as between, say, 50 and 51, but then additionally age of 0 has a meaning. And so those are the four different measurement levels or types of variables. And sometimes the blue ones, interval and ratio, is called quantitative or numeric or metric data. And the ordinal and nominal is sometimes called qualitative or categorical data. And I just some graphical, basically the same information. So nominal, ordinal, interval, they all are categories, it's all measures. But only nominal is not, the rank order is not fixed, that's for ordinal. And then equal spacing between the different values, that is for interval but not for ordinal. And then the true 0 comes with ratio. So there's a sort of a ranking between these interval levels. Now, why is that relevant? Why do I explain this in a course in statistics? Because the measurement scale has major consequences what you can do with your data. For example, if you talk about gender, being male or female, I cannot compute the average gender. It's not like, suppose male is 0 and female is 1, I cannot compute the average of that. Or if it's a country from 1 to 5, I cannot compute the average country, which is like 3.4, something like that. If 3 is the Netherlands, if 4 is Germany, 3.4 doesn't have any meaning. So the final column you can see here with nominal, I can just do counting, like there's 40 people from the Netherlands and 50 from Germany. I can do percentages, like what percentage of the sample is from Germany versus from the Netherlands. I can do these kind of things. And the same for ordinal, and I can do the same calculation, but I cannot compute the average. Well, you can compute the average, but it's meaningless. So, but if you go to a higher measurement level, I can do more and more and more. For example, for ratio, I can do even multiplication and these kind of things. So I can say, like, if someone who is 20 years old is 2 times older than someone who's 10 years old. So I can do a multiplication, or I can do these kind of things. But I can, for interval, I cannot say this. For example, what they see here, like 10 degrees Celsius is not half as warm as 20 degrees Celsius. Yeah, people are tempted to say that, but that's strictly speaking not correct. Because so this is what you can officially do, and what you're supposed or allowed to do, but what you can already see not only in practice, but also somewhat in science, and so people play around a bit with that, like saying that 20 degrees Celsius is 2 times as warm as 10 degrees Celsius, which is strictly speaking not correct. But people tend to do that. Or say a rank order of runners in a race. If you're not supposed to compute the average, but yeah, that might be tempting to do that, but it's not correct. Now that is about variables, but all these variables together combine into data sets. So multiple variables combine into one data set. And now there's different types of data, and that's also important to be aware of that. So I think the book only describes the first 2, but it's important to know the third one also. So that's a bit of extra relative to the book. The most basic one is the cross-sectional data. And that is like you have a sample of individuals or firms or whatever your subject is that you study, and in one time shot you measure a lot of variables for those. For example, you send out a survey among customers and you measure satisfaction and gender and a lot of other things about these customers, and you do it only once. So that's cross-sectional data. Time series data, which is more common in finance and in economics, where you don't do so much a sample, but you measure a large number of variables, but basically for only one thing over time. So different stock prices or different prices of materials, and you have this over a long period of time. So there's a time dimension, but you measure only those variables. So you don't have these cases so much. Now, panel data is a bit of a combination of both, where you have both multiple cases, like in survey data, but you also have over time. So, for example, you collect, you send out the same survey at a regular basis. Say every year you send out a survey to your customers, and you measure the same things over and over again. So you have multiple time points for the same cases, the same individuals, the same firms. You measure the same variables over time, and that is called panel data. Panel data is in principle what most scientists, most statisticians like, because then you can much better assess changes over time. For example, a typical example for marketing is like if you do a price promotion in a supermarket. If you don't have panel data, you cannot really see if you do a price discount and you have additional sales. You cannot really see whether it's more people buying or the same people buying more stuff, more of your product. But you really need individual data buying over time. You need to know who is buying what over time to see whether it's the same person buying more, or that you attract with your promotion new customers. So then you really need panel data to see these kind of changes over time. So in principle, panel data is the preferred option, but Or for example, if you study customer satisfaction, if customer satisfaction goes up, you really would like to know whether it's the same customers who become more satisfied. Or did the unsatisfied leave and are no longer in the survey? So what happened? Another distinction that can be made on types of data is primary versus secondary data. And that is the basic distinction is whether it's new data or existing data. So what do I mean with that? Primary data is that you as a researcher or as a student, you're interested in a certain problem, and you conduct a research project, and you collect data yourself by running an experiment, doing interviews, send out a survey, whatever you like to do or you want to do, and you collect data. That's primary data. So you can do, as listed here, surveys or all kind of different studies. So you collect the data real time. You want it now, you collect data now. And you can adjust it, of course. If you need customer satisfaction on a 10-point scale, that's what you collect. It's relatively expensive because you need to do a survey, you need to run an experiment, you need to do interviews, whatever you like. So it's potentially relatively expensive. But there's a high level of control for you. You can change variables, you can determine who to interview, you are in charge of how the data is collected. But it's time consuming and it's relatively expensive. And it's if you do it right, then you can use this to study the topic that you're interested in. So that's a nice feature of primary data, but it's also negative because it's more time consuming. But nowadays, in what I explained with big data, the importance of secondary data have grown over time. Like the example from the online retailer, they already have all these purchase data and the marketing data and the return data, and they have information what they have what they have in stock and things like that. So that's partly based on their running their business. The data is collected automatically. That's just part of what they do. So it's secondary data. The data is already there and collected or generated for another person, for another purpose. And there's all kind of and there's even companies that sell these kind of data that you can buy data from Bureau of Statistics or from market research agencies or from industry organizations and things like that. And it's typically data about the past. So it's not data that you collect now, but you have data from the past on sales on things like that. And it's less it might be cheaper and less time consuming, but you cannot really you don't have too much control on how you collect the data and what's the quality of the data. So that is a disadvantage of secondary data. And you just hope that the data is appropriate for what you want to study. If you want to study the drivers of product returns, but you don't have data on on marketing instruments, then that's not available. And of course you can combine the two. Maybe you don't have this. Maybe you want to study the drivers of product returns, and you have all these data from the online retailer, and then you conduct a small customer survey to collect additional data from customers from this online retailer, and you combine the two. So sometimes you can sort of enhance or enrich secondary data by collecting primary data that matches the secondary data. So now, what is statistics? Like I said before, it's a method to get information from the data. So there's an enormous database, and this is from a customer purchase data actually. From just one of the projects that I used to work on, and you can see it's I copied only the first 28. This is SPSS, and you see only the first 28 rows, but there's actually thousands and thousands of rows and also several hundreds of columns. So it's a massive amount of data. And how do I get information? How do I get information? What are the drivers of product returns? What is the average basket value? What is the average time between different purchases from customers? What is the impact if I do a promotion? What's the impact on sales? All kind of questions that I might have that I could address with the data. I can use statistics to get information on that. So statistics, again, graphically is like there's data. I run statistics to draw a conclusion or to get information. Now, some other terminology. This data is based on a sample, and I want to draw a conclusion on a population. So what do I mean with that? The population is the group that you wanna about which you want to draw a conclusion. Like this online retailer wants to make a conclusion about the drivers of product returns for all the items that they potentially sell. But maybe as a researcher, I cannot study all the products. Maybe they have like, I don't know, 50,000 different products for on sale, and maybe for sale, and maybe I study only 100 products. So I draw a sample of items or individuals or whatever, and the sample is the subgroup from the population, and I do the statistical analysis on the data of this sample. So graphically here, the population is where I want to make an inference. I want to draw a conclusion about the population, but I cannot study the total population, so I work with a sample that is drawn from this population. And I do my statistics on these, in this case, 5 individuals, about their average age and the percentage males and females, and the probability that they return a product, or how much they invest in stocks, or whether they might be a good employee for my firm. If you're interested in HR or whatever you're interested in, you study those 5 individuals to draw a conclusion about the population. So you need to know, if you take a course on statistics, you need to know what is a population. That is the final group that you want to make a conclusion about. But the sample is the ones that you study. Or in somewhat different graphics. So the population you don't know. There's something you want to know. For example, what's the average amount of money that people invest in stocks? I don't know that. So I draw a sample for, in this case, 12 individuals, and I measure how much money these 12 individuals invest in stocks. So I get a sort of nice histogram, and from this histogram I can compute the average and the standard deviation. So I get a graph like this, and then I can make an inference. So what is actually the mean and the standard error, the standard deviation in the population, which is more smooth, because in this case it has a nice normal distribution, and this is just a histogram based on the data that I have. So this is, and based on this I can say something about the population, namely the average amount of money that people invest in stocks is, I don't know, 2,500 per year. And that is based on these 12 individuals and this histogram. And in the end I want to say something about the population. Or in science, there's something called the empirical cycle. In science, there's oftentimes a theory about behavior of investors, behavior of consumers, the behavior of firms, the behavior of managers, the behavior of any economic agent or of markets. And based on this theory, I come up with an hypothesis. Namely, if prices go up, sales goes down, or if someone has a better training, his salary goes up, or the probability to get a better job goes up, or some kind of hypothesis. Now I collect data, so now it becomes statistics. I collect data, and I get data. These are my observations, that's my data, and I do statistical testing to get a conclusion or an empirical finding. And that leads to new theory. So that's the empirical cycle. And statistics is about data collection, data, and testing your data. So the course for here is about hypothesis, observation, testing, and getting conclusion. So basically the lower half of this plot is basically a summary of this course. So what is the rest of this course? It's about statistical analysis. First I go into details about descriptive analysis. Actually the KnowledgeClips 2 and 3 will be about that. So about graphical, that means tables and figures, and about numerical techniques, which is KnowledgeClip 3. And next, that's more typical what people think about if you talk about statistics. KnowledgeClip knowledge clip 4 to 9 is about like, okay, if I have data, how do I do statistical inferences? How do I do estimation? How do I do testing? How can I do more advanced analysis to say something about the population based on the sample, the data from the sample? Like how can I assess what's the impact of a price promotion on sales and product returns? How can I see whether there's differences between males and females on how much they invest in stocks? What's the impact, what's the relation between training of an individual and probability to get a job? And all those kind of things you may want to study. So that's the rest of the knowledge clips, and thank you for your attention, and I hope you enjoyed it and learned something, and see you at the other clips.